In this video, we are going to talk about Radon transform and projection function in Matlab and see it, what it is, and to learn more about these concepts. But first of all, let's talk about Radon transform and projection functions briefly and see what are they. So here we can see in the Wikipedia this picture. This picture shows a object, and these are the beams or rays that are illuminating to this object with this angle. And here is the detector which detects those beams, and actually it measures the intensity of these beams that are reaching to these points on the detector. So whenever these rays are illuminating to these objects, they will attenuate as they go through this object. And this detector will measure that intensity. And this graph here is the projection function that we can see. And each of these points that we have will have the radon transform. And the radon transform measures the height, if the height with respect to this axis. We can call it XP. In the Matlab, we will see it. And these values are the radon transforms of the projection function that that this figure is illustrating it. So the radon transform formula in the Wikipedia, we can see this is the formula in the Cartesian coordinate. So now let's look at the this video, short brief video, and see what it is, the projection function. So as you can see here, in this picture, in this video, so let me go back. In this short video, whenever these rays are illuminating to this pi object, they will have a projection function, and in each angle that is changing, we will have different projection functions, as you can see. So, and this is the overall very good visualization of this projection function and radon transform. Now we can go and look at the Matlab and see our example and see what it is. Now we're in Matlab. In Matlab, I have written a code which is 200 by 200 pixels, and we want us to make two circles. The big circle with the intensity of 1 and the small circle with the intensity of 1/2. So it will be gray. So if we run this code, we will have this picture. As you can see, the bigger circle with the intensity of 1 and gray circle with the intensity of 1/2. And the background will have the intensity of 0. So after having this picture, and now let's go and write the code which I have written here. So I will copy paste it here. And this is the radon transform, and we want to plot those projection functions, right? So we will calculate the radon transform of the circles which we have seen here, these circles. And the function that we are going to use is the Radon function, which is a built-in function, and it is existing in the Matlab. So we will take those our circles and with each theta angles, which are in 0, 45, 90, and 135 degrees. And then we will plot the XP, and XP, let me again go to this here, okay. And what is XP? So XP is the this axis, and here in the middle it will be 0, and it is measuring the distance of those projection functions that are going to this and making this uh, projection function, right? So XP is actually this axis. It is like x-axis, and the middle will be 0, right? So let's go back to the Matlab, and this R will be the matrix. Will be the values of those intensities that rays are passing through it. And this R with matrix, we will choose all the rows but the first column. The first column is specified to this 0 angle theta. So in this figure, we will measure the projection function and radon transforms of those circles at 0 degrees here. And similarly for other degrees, the 2 here is the second column. So it will measure the 45, and third for 90, and so on. So let's run this code and see what it will bring us. So after running this code, we can see 135 degrees. You can observe that we have other pictures as well, right? And this is our original picture. This is our original picture, and if we illuminate these two circles, this in this direction from bottom to top, and it will be parallel to the vertical axis, we will have a projection function like this. As you can see, we have a gap between those, we have distance between those circles, and it is corresponding to these values. And this is the projection axis, XP, as I have said it earlier, and this is the radian transform value. So this is for 0 degrees. For 45 degrees, if the rays are going in this direction, I mean 45 degrees with the horizontal axis, so it will be in the 45 degrees. So some rays may go through this white and big circle, and also in the gray circle. So we have projection function like this. And also for 135 degrees, as you can see, we have these two pictures will be just a mirror of each other. 45 degrees will go in this direction as I'm showing with my cursor, and 135 will be in this direction. Okay, so they will be in the mirror of each other. And finally, 90 degrees will be when the rays from left to right, and they will be parallel to the horizontal axis. So as you can see, rays are going in this direction will spend much more time in the objects of circle white and gray circle. So we will have something like this. And if we just consider, if we didn't have a gray circle and we had just white circle, the projection function may not go as high as it is right now. It might go like this, but and this additional height that we're observing here is because of this gray circle. So that's it for the radiant transform and projection function, and we illustrated these concepts with Matlab, and I hope this video was helpful for students to understand deeply these concepts, and thanks for watching.